Section 3.7, Addition and Subtraction of Fractions, Part 1. The number line can be used to add and subtract fractions in the same way that we used it to add and subtract integers. Example, compute 2/3 plus 5/3 using a number line. When we draw the number line, what is the appropriate spacing for this? It will be 1/3 increments. Now that we have the number line drawn, we will do the same process as before. We always start from 0, go 2/3 to the right, 1/3, 2/3, and then to add 5/3 we go 5 more spaces to the right, 1/3, 2/3, 3/3, 4/3, 5/3. 2/3 plus 5/3 equals 7/3. Just as before, drawing the number line every single time will become tedious, and so we want to be able to think about the number line without having to draw out all the individual spaces. Example, compute 5/7 minus 8/7. 5/7 minus 8/7. So if we start from 0, we go 5/7 to the right. If we go 8/7 to the left, we're going to go past 0. And so we know we're going to be negative. Question is, negative what? Negative 3/7. Example, compute 3/4 minus negative 7/4. 3/4 minus negative 7/4. How do you deal with subtracting a negative? Remember that subtraction means addition of the opposite, so 3/4 plus the opposite of negative 7/4 is positive 7/4. 3/4 plus 7/4, 3/4 to the right, followed by 7/4 more to the right. The answer is 10/4. But if you look at the number 10/4, you see that it reduces to 5/2. You should always reduce whenever you can. Section 3.8, Addition and Subtraction of Fractions, Part 2. When the denominators are different, the step sizes do not match up. If we think about trying to do a calculation like 1/2 plus 1/3 on the number line, here's 0, here's 1. 1/2 would be about there. If we look at the locations of 1/3 and 2/3, 1/3 would be about here, 2/3 would be about here. The spacing from here to here is much bigger than the spacing from here to here, and so all of our step sizes would be different. Furthermore, it's not clear by looking at this where exactly we would end up. 1/2 would be about that far, and if we go 1/3 over, it's somewhere in the middle here where we don't know exactly where it's located. And so instead, when we add and subtract fractions, we always need to find a common denominator. That way we break everything up into the same step size. Example, compute 3/4 plus 2/5. We can see that we have different denominators, so we need to find a common denominator. What is a common denominator for the fractions 3/4 and 2/5? 20 works, so we will work with 20 as the denominator. So we're going to set ourselves up to write both of these fractions with a denominator of 20. Looking at the first fraction, 4 times what equals 20? 4 times 5 equals 20. Second fraction, 5 times what equals 20? 5 times 4 equals 20. And so you multiply top and bottom by 4. 15/20 plus 8/20. And now we do our addition. 15/20 plus 18/20 is 23/20. Notice that we've still maintained the same presentation as before. Original problem and an equal sign, and then we work down the page with equal signs lined up. Example, compute 5/6 minus 2/9. 5/6 minus 2/9. Again, we have different denominators, so we need to find a common denominator. What would a common denominator be for this problem? A lot of students tend to blindly multiply the two denominators together to get, in this case, 6 times 9 is 54. However, that denominator is much, much larger than it needs to be, which makes all the numerators much larger than they need to be. It turns out that the least common denominator for this problem is 18. 5 times something over 6 times something minus 2 times something over 9 times something. Denominator is going to be 18. 6 times what is equal to 18? 6 times 3. 9 times what is equal to 18? 9 times 2. 15 eighteenths minus 4 eighteenths is equal to 11 eighteenths. Example, compute 3 minus 7 thirds. When doing a calculation with an integer mixed with fractions, we generally just write the integer as a fraction by writing it as 3 over 1. 3 divided by 1 is 3, so we haven't changed the value at all. We've just written it in a way that helps remind us of the process we use for fractions. We now have two fractions, 3 over 1 and 7 thirds. What is a common denominator? 3 is a common denominator. Now in this case, the 7 thirds doesn't need to be multiplied by anything in order to have a denominator of 3, so we can just leave it alone. 9 thirds minus 7 thirds is equal to 2 thirds.